Hi, and welcome to this quick look at a long answer benzene structure question. So the question gives us two structures, A and B. Both are used to represent benzene. They want you to describe with the aid of suitable diagrams, meaning you need to actually draw more than one diagram to explain your answer. The difference in bonding, so that means just focus on the bonding, not all the other things you might remember about the structure of benzene. So the double bonds actually represent the sideways overlap of p orbitals to form pi bonds at each position that's been labelled there, but not elsewhere. So that means that they are here, here, and here, where you get the sideways overlap. But in structure B, that circle represents the idea of the sideways overlap of the p orbitals all the way around the ring, forming what we call a delocalized pi system. So for structure A, what you need to do is position your pi bonds above and below the plane of the molecule at alternating positions around the ring. And the labeling that you'd need to use would be something like this. So you need to say that the pi bonds are localized. Whereas for structure B, what you would do is you'd draw the ring above and below, representing the delocalized pi system, and then put that into your answer. So the idea of localized versus delocalized is important here. The next part of the question asks you to consider some data with two reactions. So we've got the reaction of hydrogenation of cyclohexene and benzene. You can see that cyclohexene is minus 119. So looking closer again at structure A and structure B, they want you to decide which one is a better representation of benzene. So if we were to take cyclohexene, basically it contains one carbon-carbon double bond. So therefore that is hydrogenated. That's the only place in the molecule which is being hydrogenated. So that minus 119 comes from the hydrogenation of the double bond. So structure B is better because you can see it's got greater stability. There's less energy that would be released. Now, I know that it says minus 208 compared to minus 119. But let's think about what would happen if you had three double bonds like structure A. This minus 119 applies to one of them. There's another minus 119 applying to the next, and a third minus 119 applying to the third one. So adding those all up, that would actually mean structure A would have an expected enthalpy of hydrogenation of minus 350 kilojoules per mole, which is more exothermic than that of benzene, which you've got here as minus 208. Okay, so hopefully this has been a useful look at how to analyze the information. Until next time, thanks for listening and see you soon.